Hello, math people from around wherever we are. Calgary, that dot's good. How's this one? I just got to find out where my screen is here, and then we can rock. Good enough. All right, so this is going to be a fairly quick video on reviewing prime factors and how to find, I got to squat down here, lowest common denominator and not lowest common denominator, greatest common factor, GCF, and least common multiple. Factor, multiple. Remember, factors, are they going to be smaller or equal to the number, or are they going to be bigger? I hope you said smaller. These are going to be smaller than the number. Multiples are always going to be bigger than the number. Alligator teeth eats the bigger one. So the multiples are going to be bigger. The factors are going to be smaller. First thing we got to talk about is what a prime number is. Prime number. I have this little guy named Juan. Whoop. Juan represents the number 1. Okay, so a prime number is a number that only has a factor of 1 and itself. 1 is the first prime number. The only way to make it is 1 times 1. 2. Factors of 2 are 2 times 1. 3. Factors of 3 are 3 times 1. 4. Well, I can still do 4 times 1. That says plus. 4 times 1. But I can also do 2 times 2. So number 4 is not a prime number. Just so you know, number 2 is the only even number that is prime. All the rest are composite. See, composite means they have more than one prime, or more than one factor, more than one friend. What about 5? Nothing multiplies together to get 5. So the only factors are 5 times 1, or Juan if you want. 6, that's an even, not a prime. 7, well, 1 times 7 works, but then we have 3 times 3 is 6, 4 times 4 is 8. There is no other factors of 1. Now notice how we're only talking in whole numbers. So decimals don't count. I know we could go like 3.5 times 2. That doesn't count. It has to be a whole number. So when we're talking prime and composite, that's the proof. We'll get more into how to determine primes a little bit later on. But for now, we'll just put the primes up top. So we get 1, 2, that would be a 3. 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. That should be enough for now. So when we do this thing called prime factorization, what we're doing is that we are breaking the number down until we're only left with primes. We're going to be left with something called the prime factor sequence, PFS. One of the most powerful ways to break numbers down, and it's one that we often skip over in math, but if you can do this skill, so many other things become easier, which we'll get into later on in the year. So the only thing I want you to know is that if you use, sorry, I'm looking for another colored pen. If you use your multiplication chart, you are going to be able to find most of these numbers. If you can't, try and break them down in your head like we did in class. If you're still struggling with that, use a calculator. If it's even, divide it by 2. That will always work. If it's not, try 3, try 5, try 7. See if you can find some way to break these down. I prefer to actually break things down starting with prime numbers. So for 30, I would go to 5. That's a prime number. I would break this down to 5 times something. You could start with a different number. So in 30, do we have anything? I could go with 10. I could go 10 times 3. Oh, interesting. 3 is also a prime. No matter which way you break these numbers down, if you go until you have prime numbers, you'll get the same answer. So 30, let's start breaking this down. Remember, always multiplication. Always. Don't ever add these. You'll get messed up. So this is going to be 5 times 6. I know right off the bat that 5 is a prime number. Shoot. There we go. 5 is a prime number, so I'm going to circle that 5, and that doesn't come across very clearly either. Should have checked these before. There we go. 5 is a prime number, so I don't have anything more to do with that. 6, I can break this down to 2 times 3. 2 times 3 are both prime numbers. I don't have any more prime numbers in this sequence. So I'm done. The way we write them is smallest to greatest. So I have 2, 3, 5. 2 times 3 times 5. 5. That is my prime factor sequence for 30. Let's go to 45. So in 45, again, I can use 5. 5 times 9. 5 is a prime factor. 9 is not. If you're not sure, take a look at your multiplication sheet. 9 I can break into 3 times 3. Now, it's also like 3 squared, right? 3 times 3. So I'm supposed to circle that in red. There we go. So take a look at this. What is my prime factor sequence for 45? Smallest to greatest, so I get 3 times 3 times 5. If you want to get fancy, which you all can, 3 times 3 is also 3 squared, because there's 2 of them, times 5. Either one of these is right. Okay, so that's the basics of prime factoring. Let's do one big one, just so you see how it works. This is my bad side. It's hard for me to write over here. There we go. So let's do a really big one, 220. So remember, I can break this down. Half of 20 is 10, half of 1 is, or half of 2 is 1. So I could break this down pretty quick. If you need your calculator, use it. The goal is to be able to prime factor in your head. So let's do this one, 2 times 110. Any prime factors? People get sick of hearing me ask these questions, but you know what? It makes a difference. This is going to be 2 times 55. Prime factor. 55, can I put 2 in? No, I might be able to put 3, but I don't know that in my head. I'm going to go with 5. So this is 5 times 11. Ooh, that's interesting. 11, prime number. So we get to circle that. We're actually done. This one didn't take long. Prime factor sequence is going to be 2 times 2 times 5 times 11. How else can we write 2 times 2? 2 squared times 5 times 11. And that's it. So the goal here is to get really fast at this. Here's a hard one. Let's do 17. What are my prime factors of 17? In this one, it would be 1 times 17. We only have 17. 1, we never put in the prime factor sequence because it doesn't change anything. Hopefully that makes sense. If not, ask me a question next week. So here we have 3 numbers. When we're looking for something called the greatest common factor, the GCF, what we're looking for is what is the biggest number that goes into both 30 and 45? What number can go into 30 and 45? If I do a simpler example, if I have 10 and 20, these are my numbers. Well, 10 is actually a factor of 20. So the greatest common factor of this one is going to be 10. 10 goes into 10 once, 10 goes into 20 2 times. This should sound familiar with regards to our fractions. This is how we find common denominators all the time, which is why this concept is actually really useful. So what we're going to do here is we're going to look for what factors 30 and 45 share. We're just going to do the greatest common factor of these 2. So when I do this, do I have any 2s in this one? I have a 2 here, but not there. So it's not common. So this 2, I'm not going to use. I have 1 3 in both of them, right? So there's 1 3. Do I have a second 3 over here? I only have 1 3. So we've already shared 1. This one doesn't count. And then I have a 5. So my greatest common factor is going to be the product of these 2 numbers. So what we do is that we put it down. They share a 3 and they also share a 5. The greatest common factor is going to be 15. So it's what they share. So we're not going to go 3 times 3 times 5 times 5. We're going to take what they share, multiply that together. Right, let's try this one over here. Over here, I have 3 squared times 5. Here I have 2 squared times 5 times 11. This one's pretty easy to see. Do I have any 2s on this side? I don't. So these ones don't count. Do I have any 3s on that side? That doesn't count. I have a shared 5. So I can bring that 5 down into my, almost a little higher. I can bring that 5 down in.